Buddy, do another episode of Mr. Wagner's Math Help. This is my nice, beautiful desktop background, and here's the problem we're going to be going over today. So, this was a homework problem. I changed the names in it because I wanted to be involved in this trip to St. Louis. And so this comes from number 11 on the homework that is due tomorrow, January 30th. I got a request for some help on this yesterday, so here we go. The problem is Mrs. Wagner, and I've just been told my wife doesn't want to be called Mrs. Wagner. She wants to go by Miss Amanda. So to all you can call her Miss Amanda. Miss Amanda drives from Dallas to St. Louis. The length of the trip is 650 miles, and she's traveling at 50 miles an hour. Meanwhile, me, Mr. Wagner, I leave 2 hours later, but I'm traveling faster, 62.5 miles an hour. At what distance from Dallas will I catch up with my wife, Miss Amanda? So hopefully at this point in the unit you are comfortable recognizing when a system of equations might help us come to a solution. So as we can see here, there's two things going on. Miss Amanda's traveling and I am traveling. So Miss Amanda, she's traveling, and then I'm going to be a nice different color here. I'm going to go to red, and we can call Mr. Wagner. Nice patriotic red, white, and blue. So how are we going to set up our equations here? We know that distance equals speed times time. So if I keep that as our equation, I know that my wife, Miss Amanda, is traveling at 50 miles an hour, so I'm going to set distance equal to 50t. As for me, I will be traveling faster. I'll be traveling at 62.5 miles per hour. And if you recall the lesson where we talked about overtaking, you'll notice that I'm traveling faster, so I will have to overtake her. But how are we going to account for this 2-hour head start? In whose equation are we going to put this 2-hour head start? Now, I'm going to put it in the equation for my wife's speed because this is in time. But if you look here, this equation is accounting for distance. Distance is our dependent variable. So I can't just add 2 here. I need to think about what's the distance that she'll have gone in those 2 hours. What's the head start that she's getting? And if you know she's going 50 miles an hour, she's going to have a 100-mile head start. So once you set up your equations, I think you will be able to solve this problem on your own. So if you want to stop here, you can try it. But I'm going to keep going. So in the system of equations where we use substitution, I can take the d, or distance, from my equation and substitute in for the d in Miss Amanda's equation. And when I do that, I will end up with 50t plus 100 equals 62.5t. Now, I don't want us just going through these problems and just plugging in a set of steps. That's not what this is about. I want you to really be thinking, why are we doing this? What is the result going to be? And when we're solving a system of equations, you have to understand that when we set these equal to each other, we're really finding on the graph where these two lines will meet. And we know they're lines because they're in the form y equals mx plus b. The only difference here is instead of y and x, we're using distance and time, a dependent variable and an independent variable time. So really think about what you're doing as you do these problems. You might not like this way. If it's easier for you to graph, go ahead and graph it. Do what works best for you. But I'm going to take you through these two ways. So once we have this, we're just going to treat it like a normal equation where we are solving for a variable. So let's start out by getting the variables to one side. So I'm going to subtract 50t from this side of the equation, and I'll do the same thing over here. And when we do that, we are left with 100 equals 12.5t. Now, if you want to get out your calculators, You can do that, or you can man up and just do it in your head like a boss. So we're going to do that, and we're going to divide both sides by 12.5. And when we do that, we figure out that t equals 8. Now, if you can't do it in your head, that's fine. Do it on a piece of paper, but try to resist using that calculator. So what does this mean? I want you to be asking yourselves that all the time. What does this mean? This means in 8 hours, in 8 hours time, I will catch up with my wife, because this is time here. So on the graph, once 8 hours arrives, the lines will intersect. And so for an intersection point, we need more than just t. We need to find out what the d would be. So how are we going to find that out? Well, we plug this right back in to one of our equations. We could plug it into either one, but the mental math's easier over here. So I'm going to plug 8 times 50, or I guess you could say 50 times 8 plus 100 is going to give us the what the distance is. So 50 times 8 is 400, plus 100 is 500. Now, once again, thinking about what that means both myself and my wife, Miss Amanda, will be 500 miles away from Dallas when we cross paths. If you're having trouble with this, feel free to put comments below, or you can ask in class. But I think all these things are review from what we have been doing over the past couple of weeks. Now, if you're not really comfortable with this, let's take it over to the graph. We know that my wife is getting that 100-mile head start. And so I'm going to change this from being the y-axis to the distance axis. And x is going to be time, because time is independent, and distance will be dependent on our time. So after 1 hour, how far will my wife be? Well, she's going to be 50 miles further, because she's going 50 miles an hour. So you can put a dot there. Now, in the next hour, should be another 50 miles. So every 2 hours, she's going 100 miles. So I'm just going to continue this pattern here. You're realizing that we're going up 100, and I'm actually going over 2. So if you're a little confused by what I mean by going rising 100 and over a run of 2, 100 divided by 2 gives us that 50, which is the slope in my wife's equation, or her speed. So we'll come back over here, we'll finish this out. Now, we really only need 2 points for our line, but I just wanted to kind of show you what would happen as we think about this. Now, I will do my best to draw a straight line here. And that is the line of the equation for my wife. Now we gotta do me. And if we go over here, I will go back to the color of my equation, which is red. And if you look, what is my y-intercept? If you notice, I'm still in the y equals mx plus b, also known as slope-intercept form. But I don't have an intercept. That's because my y-intercept is right there at 0. And every hour, I'm going to be going 62.5 miles. But it's going to be hard to do on this graph, so I'm going to see how far I go in 2 miles. And in 2 miles, I will have gone 125 miles. So I'm just multiplying 62.5 by 2. So in 2 hours, I'll have gone 125 miles. And that's going to be my slope. So in the next 2 hours, I'll have gone another 125. And the next 2 hours, same thing. And then finally, 8 hours have gone by, and I have reached my wife. I have passed her. And from that point on, I will be in front of her heading to St. Louis, which is good, because I got to go and check in at the hotel. She doesn't like doing that, so it's a good thing I beat her to the hotel. So anyway, there is the graph representation of this system of equations. Now tomorrow we're going to be going over how to solve using a method called elimination, but remember, think about what you're doing. Don't just blindly follow steps. Think about what it means, what the intersection point means as you go through these problems. So once again, thanks for listening. Hope this helps. Good night.